In today's lesson, we're going to be learning about molecular compounds. We're going to look at the properties of these compounds, how to draw them, how to name them, and how to write their chemical formulas. Molecular compounds are when compounds made from two or more nonmetals are sharing their electrons to fill their outer valence shell. This bond that's formed is called a covalent bond. This is different than the ionic compounds we looked at earlier, where electrons were given and taken. Because molecular compounds share their electrons, they have different properties than the ionic compounds we discussed earlier. Number one, they do not conduct electricity. Number two, they have low melting points. This bond is not as strong and it doesn't take as much energy to break that bond. These compounds are soft and flexible, and these compounds have little to no solubility. That is, that they do not dissolve in water. To illustrate this unique sharing arrangement that molecular compounds have, we have some different rules for how we will draw these molecular compounds. Number one, we draw the Lewis dot diagram. So in our first example here with HCl, we'll draw the Lewis dot diagram. H is found in group 1 and has 1 electron in its outer shell. Cl is in group 17 and it has 7 electrons in its outer shell. We can draw it like this. Step 2 says that the lone electrons will pair up between two atoms to complete their valence shells. So the lone electrons, the ones that are by themselves, will pair up. And so we'll draw a circle around these lone electrons to indicate that they will be shared. Number 3 is we will draw the stick diagram. Essentially, the circles become sticks and lone pairs stay on the diagram. So the circles become sticks. So I draw my H, and there is a stick here, or a bond, with the H and the Cl. Notice here that the other electrons will stay on the diagram, like that. Our second example is looking at O2. So I have 2 oxygen atoms. Again, I'll draw my Lewis dot diagram. Oxygen having 6 electrons around it, and I will draw a second oxygen molecule. Step 2, the lone electrons will pair up, and so I'm going to draw circles around these lone electrons, and there's another shared electron here. Part 3, we draw the stick diagram. The stick diagram, the circles become sticks. So I can illustrate this by having my oxygen, my 2 oxygens, and there are 2 bonds, 2 covalent bonds between those oxygens. The pairs of electrons stay on the diagram, and so I need to make sure I illustrate that as well. So there are 2 sets for each of those. Our final example on this page is H2O. And if you want to pause the video and draw it for yourself, go ahead and do that now, and then press play again when you're ready to check your answer. Let's draw it here together. My H has 1 electron. Oxygen has 6 electrons. And we can see here that we will have a shared electron. Now in this diagram we have 2 H's. So in order to satisfy oxygen, I'm going to have another H here, and we're going to have another shared relationship. Step 3, we draw the stick diagram, and I'm going to draw it up here. I have my oxygen. The pairs of electrons stay where they are, and I draw sticks where the circles were. And there is H2O, and that's what our water molecule looks like. Unlike the ionic compounds that we looked at earlier, naming molecular compounds, we have some different rules. And we need to make sure we clearly identify the compounds as ionic or molecular because they do have unique rules. Number 1 for molecular compounds is we write the first nonmetal with the appropriate prefix. On the back of your periodic tables that you've been provided, you'll see a number of prefixes for molecular compounds. Those are below the polyatomic chart on your periodic table. We write the second nonmetal with the appropriate prefix as well, and similar to ionic, we change the ending to an "ide." So when we're doing our first example here, we have P2O5. We write the first nonmetal with the appropriate prefix. We just write the full name, so we're going to write phosphorus. And then we use the appropriate prefix. If you look on the back of your periodic table, we can see that phosphorus has 2 atoms. And so our appropriate prefix that we would put for 2 is di. And so we would write diphosphorus. And then we're going to have oxygen, again changing the ending to an "ide and adding the appropriate subscript. We can see that oxygen, we have 5 oxygen atoms, and so we can see the prefix is penta. So when we write it, we would write diphosphorus pentaoxide. Now, we often don't put vowels back to back, so we just put pentoxide. If you put pentaoxide, that's okay as you get started. But often we don't put vowels back to back there. So we'd have diphosphorus pentoxide. Let's take a look at our next example. Our next example was CF4, while C is carbon. And so we write carbon. Now on this example, we can see that carbon only has 1 electron. And when you look at your periodic table, you'll notice that for 1 atom, mono is the prefix, but it is only used on the second nonmetal. So I don't need to put a prefix here. For my second atom, we have fluorine, and we have 4 of those. The prefix for 4 is tetra. So I would write carbon tetrafluoride. And again, we change the ending to ide. Our final example is S3N. And so for S, we know it's sulfur. And there's 3 sulfur atoms. So we look at our prefix chart and simply add trisulfur. Our next element is nitrogen, and we'll change that ending to an ide, so it's nitride. And again, we see here that there is only 1 nitrogen atom, and so we need to put the appropriate prefix, and so that would be mono. So there's our naming rules for molecular compounds. Make sure you clearly identify if it's ionic or molecular. Again, these rules are different, and for molecular, we will be using that prefix chart that you'll find on the back of your periodic table. To write these molecular formulas, it's fairly straightforward. We write the symbol for the first nonmetal and use the prefix to indicate the subscript number that we're going to use. Unlike the ionic compounds, we don't need to worry about charges, and we don't need to worry about crisscrossing. The second element, we do the same thing. We write the symbol for the second nonmetal, and again, use the prefix to indicate the subscript number. So let's go through these together. Hydrogen monochloride is simply HCl. We know hydrogen just has 1 because there's no other prefix here, and mono representing 1 chlorine. And so there's no subscripts that need to be added. For our second example, we have trinitrogen pentabromide. Well, tri refers to 3. Again, refer to your chart on the back of your periodic table. So we have nitrogen, and we have 3 of those. So N3 pentabromide. And if you look on the back of your periodic table, you'll see we have Br for bromide, and penta represents 5. Our final example on this page is dicarbon hexahydride. Di is 2, and so we have C2. Hexa is 6. So make sure to note what these prefixes are. Hydride is hydrogen, so we have C2H6. You'll note here that we don't reduce our prefixes like we would with ionic. We just simply write it as it's given to us. No crisscrosses, but the prefixes will tell us exactly how many atoms we have for each compound. Now that we've gone through the rules, why don't you try this learning check? You can try naming these molecular compounds and then writing the formulas. Go ahead and pause the video now and complete your work. Press play again when you're ready to check your answers. Now that you've tried it, check over your answers here on the learning check. The one thing that you'll notice is we did get a little bored in this worksheet using a lot of phosphorus and a lot of sulfur. So we have diphosphorus monosulfide. We have again phosphorus pentachloride. Carbon monoxide might be something you're familiar with, as you have carbon monoxide detectors in your house. And we'll talk about that more in biology as a poisonous lethal gas that we need to monitor. We have diphosphorus tetrasulfide. And then when we write the formulas, again, a lot of phosphorus and sulfide. So we have PS2, N2O4. Again, we can't reduce that in molecular compounds. We just write it as it is. We have AS7I3, and then our final one, PBr5. Hopefully you got through those okay. Now that you know about molecular compounds, you might recognize some formulas and their common names as well. H2O, or water, is actually dihydrogen monoxide. NH3, you might have heard of ammonia before, and ammonia being the common name, but nitrogen trihydride is kind of our accepted chemical name. Peroxide, which is a fairly common household chemical that you might have, is H2O2 and can also be referred to as dihydrogen dioxide. Methane gas, which is produced by animals, you might have heard about it in terms of global warming, or the gas that comes out of our chemistry labs, is also known as carbon tetrahydride. HCl, which is hydrochloric acid and used in many of our experiments, is actually hydrogen monochloride as its chemical name. So there's a number of different common names that we can look at. You should be set to go on your worksheet right now. There's a worksheet for you to practice naming molecular compounds and writing their formulas. And it's important to distinguish between molecular compounds and ionic compounds because they have very different properties. Good luck.